Hello my dear students, how are you? I hope all of you are fine and staying at home safely. This is your teacher Nasim Ahmed from Ideal Public School Khatigura. So in this video series we are understanding this chapter 9 of class 9, force and laws of motion. So we have already gone through the discussion of this chapter. Today I am here with this video. Here I'll be explaining the numericals of this chapter. So I have already given the formulas of this chapter, the explanation of the formulas. So before watching this video, I suggest you to go to that video and watch that video first, then come back to this video and watch the numerical section of this chapter. And here I have selected randomly 5 questions from your textbook, and you just watch this video carefully so that you can understand each and every part of these numericals. On the next part I will be explaining the rest of the numericals. So without any further ado, let's get started. Students, before starting with the numericals, I would like to remind you some important tips that I have shared on the previous video. So first one was clear the concept. So before starting with the numericals, you have to clear the concept of that chapter. Then you have memorized the formulas, and all the formulas of this chapter have been discussed on the previous video. So you have to go to that video first and check that out, and then come to this video and watch the solutions of the numericals. Then you have to next one is find out the key point. So I have discussed about it. That's what is key point. So for that you need to read the question thoroughly, and you have to understand this. Then you can find the key point of this question. Okay, so let's start with our first question. Students, see the first question. This question I have taken from example 9.1. So the question says a constant force acts on an object of mass 5 kg for a duration of 2 seconds. It increases the object's velocity from 3 meter per second to 7 meter per second. Find the magnitude of the applied force. Now, if the force was applied for a duration of 5 seconds, what would be the final velocity of the object? Okay, let's understand the question first. An object is there, suppose, having mass of 5 kg, having initial speed u is equal to 3 meter per second. Okay, and it is some kind of force is applied on it. So suppose F, amount of force. For that the object changes the motion. Okay, changes the motion. Same object changes the motion into 7 meter per second. From the question we have found that, okay, 3 meter per second to 7 meter per second. So we know 3 meter per second is the initial speed that we denote by u, and 7 meter per second is the final speed. Okay, or we can say velocity, that we denote by v. So this force is applied for t equal to 2 seconds. Okay, time 2 seconds. So we need to find the force, the amount of force or the magnitude of force. So this is the first part of the question, and in the next part we need to find the velocity, final velocity. So here what is changed here is the duration of force applied. Okay, so here the duration is 2 seconds. Then in the second part we'll change the duration with 5 seconds. Then we'll find how much velocity will be, means the final velocity will be. Okay, so let's see how we can solve this. So here given u equal to 3 meter per second, v equal to 7 meter per second, m equal to mass, that is 5 kg, t equal to 2 seconds as we can see, and f we need to find out. So we'll follow Newton's second law of motion. So Newton's second law of motion is F equal to ma. So we know F equal to ma. A is what? Acceleration, m is mass, F is force. So we need to find this force. Okay, so for that we'll write F equal to m. In case of A, what is A? A is acceleration. A is acceleration, and we can define acceleration is the rate of change of velocity. So it will be v minus u by t. So this thing you have found already in the last in the previous chapter. Okay, the chapter motion. Okay, so from here we can put the values of the given thing. Okay, so m is 5 into v is 7, u is 3, t is 2. Okay, 2. So from here we can see this is 7 minus 3 is 4 by 2. Okay, so if we cut it, then it will be 2. So 10 What will be the unit? It will be Newton, okay, because the unit of force is Newton. So this is the solution of our first part, okay. So let's see the next part. So for the next part, we have u equal to 3 meter per second as the object is moving with the initial velocity 3 meter per second. After that, the time is changed, okay. Earlier the time was 2 seconds, now it is 5 seconds, and the mass is also the same because we are applying the force on the same object, and the force we have found, it is 10 Newton, okay. So now we will find the velocity, like final velocity, okay. From the same formula, we know F equal to m v minus u by t, okay. So we can say F equal to m v minus u by t. That means this m is with the upper part of this fraction, okay. So if you cross multiply it, it will become m. Here the denominator of f is 1, so this will be multiplied with 1, it will become m into v minus u, and this f will be multiplied with t, okay, it will be ft. So in the next line, what we can write, I'll just keep this v minus u in the left side, and I will take this m from this left side to the right side. So here it is multiplied with this part, so here it will be, means after going on the right side, it will be divide, okay. So it will be v minus u equal to ft by m. In the next line, what we can write, I will keep this v in the left side, and I will take this u, this minus u will in the right side, so it is here minus, it will be plus there, okay. So u plus ft by m. So now I will put the values here, okay. So implies I will write v equal to u, the value of u is 3, value of f is 10, t is 5, and here in the denominator we will write 5, okay, m is 5. So now we'll just cut this part because 5 cancel, then it will be 10 plus 3 is 13 meter per second. So this is the final velocity when this 10 Newton force is applied for the duration of 5 seconds, okay. So here this question ends. Let's see the next question. Next question I have taken from your exercise, question number 7. So let's see the question. The question says a 8,000 kg engine pulls a train of 5 wagons, okay, each of 2,000 kg along a horizontal track. If the engine exerts a force of 40,000 Newton and the truck offers a friction force of 5,000 Newton, then calculate first one, the net accelerating force, and the next part is the acceleration of the train. So this question is also very much easy, okay. So this question has two parts. Firstly, we'll understand the question. There is an engine, okay, train engine. We can see like in the train track there is engine at the first position, and then the different wagons are there, okay. So where we can travel or where some goods are being carried, okay. So here the weight of the engine is given. This is 8,000 kilogram, and 5 wagons are there, okay. Then the weight of each wagons are 2,000 kg. So they are moving, and it is said that the engine which is of 8,000 kg is having, or it is exerting force of 40,000 Newton, and due to the friction, the frictional force is 5,000 Newton, okay. As we know, like we know about friction, it is the opposite force that is applied, or that an object feels when it moves, okay. So this we can say, like, for 5,000 Newton is the frictional force and 40,000 Newton is the force that is the engine is exerting. So firstly we need to find the net accelerating force. So this is very easy. So net accelerating force will be like, if you subtract the frictional force from the force of engine, that the force exerted by the engine, then we can find the net accelerating force. So let's see the first part of this solution. So The next net accelerating force is equal to force exerted by the engine minus the frictional force. So force exerted by the engine is how much? 40,000 Newton, and the frictional force is 5,000 Newton. So it will be 35,000 Newton. So this is the answer of the first part of this question. Next part is the acceleration of the train. So let's see how it is done. So the solution of this part we can find by the formula F equal to ma, because we need to find the acceleration. So we have the masses, okay, masses of the engine and mass of the wagons, okay. So 5 wagons are there, we'll multiply this 5 with this 2000, then we'll find the total mass of the wagons. Then we have the mass of the engine, then we know the net force that we have just found out. So we'll just find this one by this F equal to ma. We know F, we know m, but we don't know a. So from this we can easily find out a. Okay, so let's see. So given net accelerating force is this much, F equal to, we can say 35,000 Newton, okay, or we can write 35,000 kilogram meter per second square. This one we can write, okay. So then total mass of 5 wagons is 5 into how much? 2000 kg. This will be equal to 10,000 kg, and therefore total mass of the train, what it will be? This 10,000, and in addition we have 8,000 kg of engine, okay. So it will be 18,000 kg. So now what we need to do, we have this mass, we have the force. So we will write, we know F equal to m into a. So from this we can take a here, it will be F by m. So what is F? F is this much, 35,000, and m is 18,000. So we'll cut these zeros, okay. So it will be so if you divide it, then you will find 18 2s are 36. So we'll write 1.9, okay, 1.9 meter per second square. So this will be the solution of the second part of this question. So let's see the next question, students. So this is the next question, and this question I have taken from the exercise question number 11, okay. So the question says, two objects each of mass 1.5 kg are moving in the same straight line but in opposite directions. The velocity of each object is 2.5 meter per second before the collision, during which they stick together. What will be the velocity of the combined object after collision? So this question is pretty much easy, but if you miss one point, then you you will find some kind of difficulty while answering the question. So for that there are two objects I'm drawing here, okay. There are two objects, suppose I'm drawing two objects, and each of mass how much? 1.5 kg, 1.5 kg, 1.5 kg are moving in the same straight line. So this is the line, okay, this is the line, but in opposite direction. So if this one is moving by this side, this will be moving by this way, okay. The velocity of each object is 2.5 meter per second. So here you see 2.5 meter per second, here also 2.5 meter per second. Same situation here, masses are same, the velocity by which they are moving is also same, but the difference is they are moving in opposite direction. Like one is moving in the right way and the right one is moving in the left way, okay. So the question is before the collision, okay, so during which then collision happens. So in the next scene they are colliding with each other, it's obvious that they are moving in the opposite direction. So one time will come that they will collide with each other. So same object, 1.5 kg, 1.5 kg. So what it says, they stick together after collision, they just stick together, they don't separate from each other. Okay, what will be the velocity of the combined object after collision? So here you can see, like, the mass, as they are combined, the mass will be 1.5 kg plus 1.5 kg, it will be 3 kg. Okay, 3 kg, and we need to find the velocity after the collision. So for this we'll use the momentum theory. Okay, we'll find the momentum before collision and momentum after collision. From this we can find the velocity of the object. Okay, so let's see how it is done. So here you see, given mass of the object is m1 m2, m1 equal to m2 equal to we can write 1.5 kg. Okay, that is given in the question. So velocity of the first object is v1, I am denoting it with v1, it is what, 2.5 meter, and the velocity of the second object is v2, which is equal to minus 2.5 meter. So why it is minus? So as you can see in the diagram, this velocity is in this direction and it is opposite of that, that's why it will be minus. It is in the opposite direction. So if it is plus, then it is minus. If I consider this velocity as plus velocity, then this will be negative velocity because it is opposite in direction. Okay, so here we'll see so velocity of first object is 2.5 and the velocity of second object is minus 2.5. so from this we can write, so this case here is what is the condition before collision. Okay, so we'll write momentum before collision equal to, so the formula is m1 v1 plus m2 v2. So now I'll put the values. So m1 is 1.5 into 2.5 plus m2 is 1.5 into minus 2.5. So from this you can see this one is plus, this one is also plus. So if you multiply this, some value we will find. Okay, and after multiplying this one also the same value, because we are multiplying the same numbers. Okay, same numbers, so same value will be found, but this one plus minus, it will be minus. So this one will be plus, this one will be minus, that means they will cancel each other. Okay, so the answer will be 0. How you have done? We'll multiply this one. Okay, we'll multiply this one, then some value we'll find, that will be plus into plus is what, plus itself. Okay, so it will be plus some value, and same number, well, we are multiplying, but here you see plus minus, it will be minus. So same value here is plus, here is minus, so they will cancel each other and it will be 0. Okay, so momentum before collision we have found as 0. So let's see how we'll find the momentum after. So after collision, both the objects are combined, as you can see in the question. Okay, in this diagram, both the objects are combined. So what will be the mass here? 3 kg. Okay, so we'll write after collision mass equal to 3 kg. Then we have velocity. Let the velocity, we don't know the velocity, so let the velocity be velocity equal to v. Okay, v, we have just assumed this one as v. So this will be momentum after collision. Momentum after collision, it will be mass into velocity, mv. Mass is 3, velocity is v. So we can say momentum, we know, means from the conservation of momentum, so we know from the law of conservation of momentum before collision is equal to momentum after collision. Momentum before collision equal to momentum after collision. So we know momentum before collision is 0 and after collision is 3v. So if you keep this v, it will be what? It will be 0 divided by 3, it will be 0. So from this we can understand that the velocity after the collision will be 0. Okay, so this is the end of this question. I hope you have understood. So let's see the next question. Students, the next question I have taken from exercise question number 13. Okay, so let's see the question. A hockey ball of mass 200 gram traveling at 10 meter per second is struck by a hockey stick so as to return it along its original path with a velocity at 5 meter per second. Calculate the magnitude of charge of momentum occurred in the motion of the hockey ball. Change of momentum occurred in the motion of the hockey ball by the force applied by the hockey stick. Okay, let's understand it first. Okay, without understanding we cannot proceed. Okay, so suppose there is a ball, a hockey ball. It is coming towards a hockey stick. We can say, I'm drawing it. I don't know it is perfect or not, but somehow I have drawn it. So there is a hockey stick and this ball is coming towards it. The ball is having mass 200 gram. Okay, 200 gram. So it is coming towards the hockey stick with a velocity of 10 meter per second. It's struck by this hockey stick. Then what happens? It goes by the same direction it came, okay, earlier. So firstly it is coming in this direction, and after striking it goes in the same direction but with the velocity of 5 meter per second. Okay, so what we need to find? We need to find the change in momentum. Like firstly it will be the change in the initial position, like in the first case. Okay, means we can say before collision, and after that, after striking, it goes back in the same direction. That will be momentum, we can say, after collision. Okay, so we need to find the momentum in both the cases, then we can easily find the difference, okay, or the change in the momentum. So let's see how it is done. So here you can see, given mass of ball m equal to 200 gram, we'll convert it into kilogram. So it will be 200 divided by 1000. Okay, it will be kilogram. So it will be if you cut these two zeros, it will be 0.2 kilogram. Then we have initial velocity of ball is how much? 10 meter per second. From the question we can see. Okay, from the question. Then we have we can find therefore the initial momentum. What is the formula? Mass into velocity. Simple. Mass is 0.2 and velocity is 10. It will be 2 kilogram meter per second. So this is the initial momentum. Let's see the final momentum. So the final velocity of the ball. What is the final velocity of the ball? We will denote it with V, we can say, or U2, simply we, no matter. So here you see the ball is striking with the hockey stick. After that it has the velocity 5 meter per second. So this will be the final velocity, and as you can see, this motion is in the opposite direction of the initial motion. Initial motion is in this way, and after colliding with this hockey stick it goes in the opposite direction. So it will be minus 5 meter per second. Okay, so it will be minus 5 meter per second. So therefore we will write final momentum equal, mass is 0.2 kg into minus 5 meter per second. So it will be 1 minus 1 kg meter per second. So from this we can find the change in momentum. Therefore change in momentum equal to, so final momentum minus initial momentum. Final momentum minus initial momentum. So what is the final momentum? This is minus 1 kilogram meter per second. And what is the initial momentum? This is 2 kilogram meter per second. So it will be minus 3 kilogram meter per second. So this will be the answer of this question. Okay, so this question is also very much easy. I hope you have understood. So if you have not understood, you can directly ask me, or you can watch this video again, okay, or this part only again and again you can watch and you can understand it, I know. So let's see the next question. So students, this is the 14th question of your book. As you can see, the question says a bullet of mass 10 gram traveling horizontally with a velocity of 150 meter per second strikes a stationary wooden block and comes to rest in 0.03 second. Calculate the distance of penetration of the bullet into the block. Also calculate the magnitude of the force exerted by the wooden block on the bullet. So this question is pretty much easy, but you have to understand it first. Okay, so I'll be explaining it now. Let's see what the question says. A bullet is there, okay, of mass having 10 gram, and it is moving with a velocity of 150 meter per second, and it strikes a wooden block, okay, wooden block. And after that, when it hits, then the velocity becomes 0. That means it stops. Okay, so the duration means after hitting the wooden block, to become at rest from this 150 meter per second velocity, it comes to 0 velocity. Okay, so it needs 0.03 second. Okay, after hitting the block, it comes to rest, and the duration which it requires to come at rest from this velocity, this much velocity, is 0.03 second. So what is the question? The question is how much this bullet has penetrated the wooden block. Okay, so after striking, it will penetrate and it will go inside this wooden block, isn't it? So how much it penetrates means what will be the distance? Okay, what is the distance of penetration? First question. And the second question is how much force is exerted by this wooden block on the bullet? Because you see, to stop this bullet, the force of this bullet is in this direction, and it has to exert some kind of force on this bullet to stop it, isn't it? Otherwise it cannot stop. So what is the amount of the force is the second question, and the first question is how much distance this bullet has penetrated on the wooden block. So this is the question. Let's see how the solution is. So here you can see mass of the bullet is 10 gram. So we need to convert it into kg. So 10 divided by 1000, it will be 0 will be cancelled. It will be 0.01 kg. Okay, 0.01 kg. Then you have initial velocity u equal to 150 meter per second. This is the velocity of the bullet. Okay, then final velocity of the bullet v is 0 because the bullet is coming at rest, as you can see in the diagram. Okay, then you have time is 0.03 second is required. Then you have acceleration a we need to find out. Then the distance of penetration we need to find out, and the force applied on the bullet by the wooden block we need to find out. So let's find out the acceleration. So we know this is the first law of motion. So we know v, the amount of the value of v is 0, u is 150, a we need to find out, and we know about t 0.03. Okay, so from this I have kept this part on the right side, a into 0.03 on the left side. Okay, so it will be minus. So if you take a, then this 0.03 is multiplied with a, this will be going there by in divide with 150. Okay, then what it will be? It will be minus, obviously, and result will also be minus. So if you want to remove this point, what you need to do, we have to multiply in the above, because here you have 1 2, so I need to multiply 100 in the above if you want to remove this point. Okay, then 5 into 3 is 15, then you have 0 here, so 50 into 100, that is 5000 meter per second. So it is minus, and because you know what, this acceleration is in the opposite direction of the motion of the bullet, that's why this is minus. Okay, so students, for finding the distance of penetration, we will use this formula. This is the second law of motion. The formula is s equal to ut plus half it square, as we want to know like what is the value of s here. Okay, so we'll put the value of u, t, a and t. Okay, So u is 150 initial velocity, t is 0.03 as we know, then half a is how much, just we have found out 5000 meter per second. Okay, this one we will put, so minus 5000 meter per second into time is 0.03. okay, 03 whole thing square. So we'll cut this 5000 with 2, it will be okay. So this will be the result after cutting it. Then if you multiply this one, it will become 4.5, and after multiplying these two means we have to find the square of this one, then you have to multiply with 2500, it will become 2.25. so the answer will be 2.25 m, okay, meter. So this will be the distance of penetration of the bullet through the board, okay, this wooden board. Then we have to applying F equal to ma. We need to find the force by which it stopped the bullet. So we'll use this formula, F equal to ma. We don't know about F, so we know about mass. Mass is how much? What is the mass of the bullet? The mass of the bullet is 0.01 kg, and acceleration we have just found is minus 5000 okay, meter per second square. So this is the acceleration, and this is the mass of the bullet. So after multiplying, what we will get? We will get minus 50 Newton. So this is the solution of this part. Like three things the question asked. Firstly, the acceleration, then you need to find the distance of penetration. Acceleration, because if you want to find this distance of penetration, you need the acceleration. That's why we have just firstly we have found out the acceleration, and for finding out this force also we need what? Acceleration. F equal to ma. For applying this formula we need what? The acceleration also. So here you have the distance is how much? 2.25 meter, and this force is minus 50 Newton. You may have a question that why it is minus 50 Newton, because you see the bullet is coming in this direction and this board is just opposing the motion of the bullet. That's why this wooden block or wooden board, we can say, should exert the force in the opposite direction of the bullet, isn't it? So that's why this minus is there. Okay, this is the end of this question. I hope you have understood, and this is the last question that we have done for this video. So in this video we have done 5 questions. In the next video we will do more questions, and study hard at your home, because after this vacation you have exams and you have to be prepared for exams. So I am signing off for now. God bless.